So today we are going to be talking more about logarithmic functions. When we're talking about graphs of logarithmic functions with some base b, meaning it's not a common log. Common log meaning base 10, okay? If we have any other base and the base isn't 10, we can use the change of base formula to rewrite any logarithmic function, okay? So if I take log base b of x, remember I can use change of base, I can change it to any one I want. So I can change this to natural log of x divided by natural log of b, and that's where they're getting this from, okay? And then what they do, and this is so that you can see the transformations, they just say that if the top thing is your ln of x, okay, if I basically factored out ln of x, what that would leave would be 1 over, like if you took this out and put it to the side, that would leave 1 there. So that's why they write it this. And the reason they do it is because this right here will be your vertical stretch or shrink. Okay? And then another interesting property of logarithms, which makes life a lot easier, is whenever you have this log and your base is a fraction, you can rewrite it like this, which basically what it takes is, and it has something, without going into too much explanation, it has something to do with, that would be b to the negative first, and so this negative comes out, and then you can just write it as log base b of x, which then you can rewrite as a negative natural log of x divided by natural log of b. And again, then you could write that as a negative 1 over natural log of b times natural log of x. Okay? And why do we want to do that? Well, it says describe how to transform the graph of f of x equals ln of x into the graph of the given function. Sketch the graph by hand and support your answer with a grapher. All right, so on this one, I can rewrite this as ln x over ln 5. Okay, and the reason now is because now if we wanted to actually solve this, we could using a calculator, because we changed the base to something the calculator understands, which is a natural log. So you could actually use a common log too. But at any rate, this would be, if I factor out that top, this would be 1 over ln of 5 times ln of x. So this is going to be my vertical stretch. So to describe how to transform, it's going to be a vertical stretch of, and you type this in, 1 divided by the natural log of 5, is 1 divided by natural log 5 is, so it's got a vertical stretch of, no, it's actually got a vertical shrink because the amount is 0.6213 blah 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 blah, which is between 0 and 1, so that's going to be a vertical shrink. And then to graph it, all that means, guys, is, I mean, they want us to do it by hand. All right, the natural log function always passes through 0, 1, and it comes down like this. Okay, so if I'm going to vertically shrink it, that's going to make it a lot lower. And if I check it on a graph, there is, yeah, there's the graph. So there's the blue is the mother, and you see how mine, the black one, they shrunk it vertical. Okay? Alright, so if I do this one, okay, anytime I see my base has got that fraction, I'm using this property, which means I can rewrite this as negative log base 4 of x, which means I can write that as a negative natural log of x over natural log of 4. And I can write that as negative 1 over the natural log of 4 times the natural log of x, which means this negative is going to reflect over x, and the 1 over ln 4 is going to be a vertical, I don't know if it's going to be a stretch or a shrink, let's see, 1 divided by ln 4, and you get, it's going to be a shrink. It's going to be a shrink of 0.5 7, 2, 1, 3, blah, 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 blah. Okay, so what I'm expecting to happen is, here's mother. I'm expecting it to reflect over x, which means, I don't draw these very well. It will do this, yes, and then it's going to shrink, so it's going to be a lot lower. Let's see how close I am. Sorry, I thought yep, and there it goes. Okay, blue would be mother. Black turns upside down, and see how much shorter this distance is compared to that distance? It shrunk. Alright, so describe how to transform this graph and graph the function. Hit pause, come back when you're ready. And hopefully you got A. I would rewrite this as ln of x over ln of 4, which I would rewrite as 1 over ln of 4 and times ln of x, which means I'm going to have a vertical shrink of this. They didn't turn it into a decimal, but that's going to be my vertical shrink, which means I'm going to take mother, who would do something like this, and I'm going to shrink her down. Okay, none of the other ones are even facing the right way. Alright, so it's got to be A. Alright, try B. Hit pause, come back when you're ready. Alright, I can rewrite this as negative log base 5 of x, which can be written as a negative ln of x over ln of 5, which can be written as negative 1 over ln of 5 times ln of x. The negative is going to reflect it over x, and the 1 over ln of 5 is going to be a vertical shrink. So if this is mother, reflecting over x is going to turn her upside down and shrink her. So it's going to make it shorter, which is this one. Alright. So how do you apply the properties of logarithms to graph logarithmic functions? You use the change of base to rewrite log base b of x as the natural log of x over the natural log of b, and then you can get your transformations from there. Alright, so a little bit of homework help. These are just like the ones we did. So again, you'd rewrite this as ln of x over ln of 7, split it, and sketch the graph and check with the grapher and describe the transformations. Okay, remember this one's going to translate into a negative log base 3 of x. And these ones you're matching on your homework. Again, look at what your transformations do. This is going to reflect over y. This is going to move it right 2. This is going to move it right 2. And this is going to be, be careful on this one. This one's going to be decay because your base is a half, so it's got to be going this way. Again, 3 units to the right. This is going to be reflect over y and 3 units right. Alright. Earthquakes. The Richter scale magnitude R of an earthquake is based on the features of the associated seismic wave and is measured by the Richter scale value is, R is the magnitude of the earthquake, is log of A, which is the amplitude, divided by T, which is the period, and B accounts for the weakening of seismic wave due to the distance from the epicenter. Compute the earthquake magnitude R for each of the set of values. So if I look for A, it's telling me to find R when A is 250, T is 2, and B is 4.25. We can use the calculator because this is base 10. So I'm going to type in log, and it opens parentheses, so do 250 divided by 2. Close your parentheses, and then hit plus 4.25. And the Richter scale would be 6.35 if I rounded. Okay? So for A, the Richter scale value, it's a 6. It was a magnitude of 6. For B, they want me to find the Richter scale value when A is 300, T is 4, and B is 3.5. So if I type that in, log of 300 divided by 4, parentheses, plus 3.5, I get 5.38 if I round. Okay? Oops. So, and then we have this light intensity in Lake Erie. It says the relationship between intensity I of light in lumens at a depth of x feet in Lake Erie is given by this equation. So I want to know what is the intensity at a depth of 40 feet. So they're giving me an x. So I have log of I over 12 equals negative 0.00235 times 40. So I'm going to figure out what that is first. Negative 0.00235 times 40 is negative 0.094 equals log of I over 12. Now, what I'm trying to do is to get I alone. To get rid of a log, you roll it away, but the base has to move over. So I roll the log over, the base moves over, and I have I over 12 equals 10 caret to the negative 0.094. So if I type in that, 10 caret negative 0.094, I get 0.80537844412. Again, you don't have to write it all. I just suggest that you don't round until the very end. To get I alone now, I'm going to multiply both sides by 12. And my I is, well, that's on my screen, I type times 12. And I get 9.6645. Let's go out two places. It'd be 9.66. All right. So, how do you apply the properties of logarithms to solve exponential and logarithmic equations algebraically? Well, you plug in your values and solve. Sometimes you have to use roll the log, and at this point you either have to make your bases, either the calculator works because the variable isn't a variable anymore in the air, or you'd have to try and make the bases match, or you'd have to roll the log and get x alone that way. Alright, so we are at homework, which means we are done. So happy homeworking, and I'll see you.